Alright, this is part 2 of the video. Number 5. You're given two functions, f of x equals x plus 1 over x minus 1. G of x equals 1 over x. So you're asked to find the following. In A, you're asked to find f plus g at x. So you just take f of x plus g of x. So that just equals x plus 1 over x minus 1 plus 1 over x. Now you simply got to add those fractions together. So remember, when you add two fractions together, you have to have the same denominator. So the least common denominator is x times x minus 1. You just multiply the denominators together. So now you got to multiply each fraction by the missing factor of the LCD. So you multiply the first fraction by x over x. Then you multiply the second fraction by x minus 1 over x minus 1. So when you do that, you're going to get x times the quantity x plus 1 in the numerator, and that's going to be all over x times x minus 1 in the denominator, plus the second fraction, I'm going to have 1 times x minus 1 in the numerator, which is x minus 1. Then you're going to have x times x minus 1 in the denominator. So now they have the same denominator. So I could write them over the same denominator, which is x times x plus 1 plus x minus 1 all over x times x minus 1. Alright, now you want to simplify the fractions. So you want to combine like terms in the numerator. So x squared plus x, just distribute the x, plus x minus 1 all over x times x minus 1. Combine like terms in the numerator, so x squared plus 2x minus 1 all over x times x minus 1. Okay. Now the numerator is a quadratic, so I want to see if that factors. And if I do that, x, so the factors of 1, which give me 2, are going to be what? So negative 1, that would give me, so are there any factors of 1 that would give me 2? Well, 1 times 1 adds up to 2, but I would need plus 1 times plus 1, but I have negative 1 here, so that's not going to factor. So yeah, that's not going to factor. So since it doesn't factor, that's as far as I can go with it. So yeah, so that's as far as I can go with it right there. Alright, letter B. I have f dot g at x, which is the same thing as f of x times g of x. So f of x is x plus 1 over x minus 1, and g of x, you're multiplying that by 1 over x. So when you multiply fractions together, you just multiply across. So x plus 1 times 1 is x plus 1. X times x minus 1 is just x times x minus 1. And since the numerator and denominator are factored, that's it. That one was, pretty easy. Adding's a little longer because you have to find the least common denominator, then multiply each fraction by the missing factor over itself, and then combine them into one fraction, simplify it, and multiplying, just multiply across and cancel out. Letter C is f over g at x, which is the same thing as f of x divided by g of x. F of x is x plus 1 over x minus 1, and that's all going to be divided by 1 over x. That's a complex fraction, which, when I rewrite that as this divided by 1 over x, right, that's the same thing. I just use the division symbol. To divide fractions, you just change just the multiplication and take the reciprocal of the second one. So that's going to be x plus 1, x minus 1. Division becomes multiplication. 1 over x becomes x over 1. So now when you multiply this, you're going to have x times x plus 1 in the numerator, all over x minus 1 times 1, which is x minus 1 in the denominator. That's it. That's factored, so that's it. Number 6 is finding the difference quotient of f of x equals negative 2x squared plus x plus 1. The difference quotient, remember, it's f of x plus h minus f of x all divided by h. So, the algebra behind this could get a little crazy, but you just take it step by step. So the first thing I want to do is find f at x plus h. So wherever you see an x, you're going to replace it with x plus h. So I'm going to have negative 2. And since I had x squared, now I'm going to have x plus h quantity squared. Plus another x is another x plus h, and then plus 1. So now I want to, I want to FOIL that out and combine like terms. So I'm going to have negative 2 times x plus h times x plus h plus x plus h plus 1. Let's FOIL out the x plus h's. So that's going to give me x squared plus xh plus hx plus h squared, close parentheses, plus x plus h plus 1. Let's combine like terms inside here. So I'm going to have x squared. xh and hx are the same thing, so that means I have two of them, 2xh. Plus h squared, close parentheses, plus x plus h plus 1. Distribute the negative 2 now. So I have negative 2x squared minus 4xh minus 2h squared plus x plus h plus 1. Okay. So that is what f of x plus h is equal to when it's all said and done. That's this part right here. Now I'm going to subtract f of x from that. F of x is the given function, right? So I'm going to take this and subtract f of x. So I'm going to have this, right? So f of x plus h minus f of x, what's that going to equal? This Let me copy it down. Minus the whole function. Now don't forget to include the parentheses for the whole function. So that's minus 2x squared plus x plus 1. If you forget to put parentheses here, you're going to screw this up. So when you do that, you're going to get minus 2x squared minus 4xh minus 2h squared plus x plus h plus 1. Distribute the negative. You're going to get positive 2x squared minus x minus 1. Now here's where the magic happens, or here's where some stuff cancels out. All right, the minus 2x squared and the positive 2x squared, they cancel. The plus x and minus x, they cancel. The plus 1 and minus 1, they cancel. So I'm left with minus 4xh minus 2h squared plus h, and I think that's it. Yeah, this one, and this one. Everything else cancels out. So that's what the numerator of the difference quotient is. Minus 4xh minus 2h squared plus h. So now I take that and divide it by h. So minus 4xh minus 2h squared plus h all over h. Now when we did this in our notes, the h in the denominator should cancel out. If it doesn't, you did some algebra incorrectly. So if you notice, every term in the numerator has a GCF of h. So I can factor an h out, and I get minus 4x minus 2h plus 1. Right? All over h. So then these h's cancel, which is exactly what should happen. So then I'm left with minus 4x minus 2h plus 1. And that's the difference quotient. So, finding the difference quotient, the algebra could get a little nuts, but as long as you take it step by step, you'll be okay. Okay, number 7. So number 7 involves using the graph on your sheet. You have the graph on the piece of paper. I'm just going to answer the questions here. So letter A says I want to find what are f of 2, f of negative 2, and f of 4. So if you look at your graph, right, if you look at the graph on the sheet, f at 2 is so 2 is the x-coordinate. So f at 2 is going to be the y-coordinate, which is negative 1. And that's it. F at negative 2. So negative 2 is the input, which is the x-coordinate. The output is 1. That's what the function is. 4 is the x-coordinate. That's the input. The output is the y-coordinate, which is f of 4. So 4, the y-coordinate is 3. That was it. No problem to it. So we're just going to keep referring to that graph for the rest of this problem. What is the domain of f of x? So if you look at the function, right, that's graphed here, this is the function. Notice there's an arrow right here, which means it goes down and to the left forever, right? So remember, the domain is the x values, right? So since it goes down forever, that means it's going to go to the left forever as well, because as it goes down, it goes to the left as well. So if it's going to the left forever, that means it's going out to negative infinity, right? So the smallest value is negative infinity, because that arrow indicates it goes down and to the left forever. And it goes to the right all the way out to 4. The furthest x value to the right it goes to is 4. And since there's a solid dot there, that means the furthest right it goes to is going to be close bracket of 4. That's it. The range. So, so we already said it goes down forever. So the smallest y value, or the y value, goes down forever and ever, which means it's going down to negative infinity. And then it goes up, and it goes up to the highest y value, which is going to be the y coordinate, which is 3. And since this is a solid dot, 3 is included. That's the range. Letter D. List the x and y intercepts. So just look at where it crosses the x-axis and y-axis. So it crosses the x-axis here and here. This is the point. So this is the point 3, 0. And then the other one. So since this point is going to be what? Negative 3, 0. The y-intercept is where it crosses the y-axis. So the only place it crosses the y-axis is at the origin right here. Which means, actually, we have another x-intercept. I forgot about that. 0, 0. My bad. And then the y-intercept is also 0, 0. That's it. Yeah. The origin is also part of both of them. Letter E. How many times does the line y equals negative 1 intersect the graph? Well, the line equals negative 1 is a horizontal line. So this is negative 1. That right there is the horizontal line, negative 1. So if I were to draw a little dashed line here, that dashed line right there represents y equals negative 1. So the graph crosses here and here. So it crosses it twice, right? It crosses it there. That's once. And right there is twice. Now I don't know what that ordered pair is. I don't know because it's not labeled. But I know that this one is 2, negative 1, right? The y coordinate is negative 1. That's a dead giveaway. It crosses it twice. So how many times does the line negative 1 intersect the graph? Twice. Once, twice. So E is twice. F. For what values of x does f of x equal negative 3? So you just got to look at the ordered pairs where the y coordinate is negative 3, right? You're finding where y equals negative 3. Well, y equals negative 3 right here. So what are the values of x where that occurs? Negative 4, and that's the only one. That's the only one. So letter F, for what value of x does f of x equal negative 3? X equals negative 4, right? Nothing to it. Letter G. Identify the intervals on which f of x is increasing, decreasing, or constant. All right. So it's increasing if it's going up from left to right. That, you know that. So from left to right, this is going up until I get to this point right here. All right. So I'm increasing on this interval. I'm going up from left to right. Now I'm increasing there. Now from negative 2, 1 to here, I'm decreasing. So from negative 2, 1 to 2, negative 1, I'm going down from left to right. That's going down. And then from 2, negative 1 to 4, 3, I'm going back up again. So actually on this function, there is no, there's no horizontal line, so there's no constant intervals. So the intervals on which I'm increasing and decreasing and constant. So like I said, constant, there are none. There are none for that. The intervals on which this is increasing are the intervals that are going up. So this interval right here, well, when I'm talking about the intervals, I'm talking about the x values. So identify the intervals on which f of x is increasing, decreasing, or constant. So I'm talking about the x values there for f of x. So the x values on this interval are from negative infinity up to negative 2. That's for increasing, including negative 2. And then from 2 to 4, including 2 and 4. So union 2 to 4. The decreasing interval, there's only one, and it goes from negative 2 to 2. That's the only one. Technically, if I want to make a little change here, technically you don't need to include brackets here. You could have open parentheses because what's going on at the point is neither increasing nor decreasing. So I guess technically you could keep an open parentheses there. Just as long as you clearly identify the interval, you're fine. Letter H. Identify the local minimum and local maximum. So remember, you have to have an interval around a local max or min. So yeah, that might be the highest point on my graph. It's not a local max because I can't construct an interval around it. I can't construct an interval over here because the graph ends there. So my local maximum is going to be right here because I can construct an interval around that as big as I want. So this right here, this negative 2 comma 1, is a local max. And that's the only one. That's the only local maximum. 4 comma negative 3 is not a local maximum because it's at the end. And remember, local extremum can only occur within the function, like within it, in the guts of the function. The endpoints is where absolute extremum occur. Local min is going to be 2 comma negative 1 because I can construct an interval around that. Now I, absolute max and absolute min. So the absolute maximum is the highest point on the function. And it could be at the endpoints or in the middle. It doesn't matter. And since the highest point here is that one, that would be my absolute maximum, 4 comma 3. And I don't have to have an open interval around it. It could be at an endpoint. That's fine. So my absolute maximum is 4 comma 3. It occurs at 4 but has a value of 3. The absolute minimum, now if you notice here, we already said that this graph goes down forever and ever. So since it goes down forever and ever, you know, I'm not going to have an absolute minimum because it keeps going down and it never stops. So there is no absolute min. There is none. Because this graph goes down forever and ever and ever, and I don't know where it stops. So there is no absolute minimum. So that's it for number 7. And that is the end of page 2 of your review, so that'll be the end of this video. That will be the end of part 2.